We are going to learn something like, I don't know, a bazillion derivative rules before the year's over, before the semester's over. It seems like it, but I mean, they just, they build on each other. There will be some derivative rules later on that you'll really have to focus on memorizing. These we'll use, pretty much the ones we're using right now, we're going to use them so much that you're just going to know them. It's not even going to feel like memorization because you're just going to know. Okay. We're going to start very basic and go from there. Okay, so our first is the derivative of a constant. And I almost wish we didn't start with this, but it is what it is. So the derivative of a constant is 0. So what's a constant function look like? A flat line, yes? If we're talking about, a constant function, so for instance, f of x equals c, which in my brain I then turn that into y equals c. Well, what is that? That is a horizontal line at the value c. Okay? With that in mind, what is the slope of that line? 0. Okay? The slope of this line is 0. So thus, what do we know? The derivative is 0. Now, right here, this is one way you'll see derivative expressed. This is saying d dx, the derivative of c, is equal to 0. So the derivative of x, or the derivative of c with respect to x, is equal to 0. Okay, so y equals -4. We're being asked to find the derivative of all of these. So if y equals -4, I'm going to use the notation y prime on this one. What is y prime? 0. The derivative of a constant number is always 0. If s of t is 45, what's s prime of t? 0. Derivative of a constant function is always 0. F of x is 0. What's f prime of x? 0. Kind of a tricky one in a way because my brain wants to go past that. But think again, what's the line y equals 0? It's a horizontal line, isn't it? So it's still 0. Okay. Y equals k pi over 2. I guess it doesn't really specify here, but what's k likely representing here? A number. So k is a number. Pi is a number. 2 is a number. So k pi over 2 is a constant. So the derivative of k pi over 2 is 0. Be aware when they throw in things like, this is all derivative with respect to x. When they throw in things like k is often a constant. C is often a constant. I'm not going to say always, but they represent constants. Okay. The derivative of x is 1. Okay. So derivative of x. What's the equation? What's the equation x looks like? Or in other words, y equals x. The equation y equals x is that perfect diagonal line, right? So if you have that being the equation of y equals x, what's the slope? The slope is 1. Okay? Derivative is slope of the tangent line, right? Or it's slope. In this case, it's just a line, so it's just slope. So, with that in mind, f of x equals x. What is f prime of x? What was it? 1. Okay. If s of t equals t, what is s prime of t? 1. And how do I know t represents a variable here? Yeah, s of t, that's saying the function s in terms of t. So t is a variable. X of t equals t. What's x prime of t? It is 1. Okay. Got some very basics out of the way, right? Okay. The power rule. Looks confusing. Once you get the feel for it, it's a piece of cake. It's the one I've been using. It's the one I use in my brain when I say, oh, x squared minus 5x. Oh, that derivative is 2x minus 5. It's power rule. Okay? So you won't ever think of it as power rule probably after you learn it, but it's very basic. If n is a rational number, then the function x of n is differentiable, and the derivative of x of n is n times x to the n minus 1. So notice, based on x to the n, the derivative is you multiply by n out front, and then in the exponent you do n minus 1, so you subtract 1. So basically, I move the power, I move the power out front, and multiply the power out front, and subtract 1 from the exponent. So, y equals x squared. If I'm talking y prime, okay, so think of this as x to the n, right? That 2 is going to go where? Out front, so 2 times x to the, and then in my exponent it's going to be 2, take away 1. You're always subtracting 1 from the power, so 2 minus 1. Obviously, I'm not going to leave my answer like that. What is the derivative of x squared? 2x. So you move the power out front, and you always then reduce the exponent by 1. F of x equals x to the 4th. I want to know f prime of x. You move the 4 out front, and then x, and then you subtract 1, so 4 minus 3. So yes, the derivative is, I wrote the wrong thing up there, didn't I? I don't even know if you guys saw it, because I don't know if you were watching it, but I wrote 4 minus 3, because my brain was going to 3, wasn't it? 4 minus 1. So far, so good? Okay. Those were the easy ones. Those were got to break the ice. Y equals the square root of x. And we're being asked for y prime. That's a start, yes. So, have we all clued in at this point? Square root of x. Do we have a rule for the square root? No. You change it to a power. And so realizing that square root of x is the same thing as saying x to the 1/2. There are lots of things in calculus that to take the derivatives, you have to change them to power form, exponent form. So, okay, so you guys were following. Move the 1/2 out front, 1/2 x, and then when you do 1/2 and you subtract 1, that does put you at 1/2 x to the negative 1/2. Now, how do we feel about negative exponents? Okay, we don't get to leave negative exponents. So, while I said yes, we were starting on the right track, we have to go one step farther. How could I rewrite this? Move it to the denominator. So, what do we know about the 1/2? The 2 is already in the denominator, yes? The 1's going to stay up top. X to the negative 1/2. Move that to the denominator. It becomes x to the 1/2. So if I say 1 over 2x to the 1/2, or what else could I write that out as? 1 over 2 square root of x. We're stopping there. Okay, you don't necessarily see them rationalized. It is very typical to leave the square root in the bottom in calculus. I'm not saying you don't need to know how, but okay, are we good on that one? Okay, tell me if you're not, right? Okay, D. G of x is 1 over x. So I want to know G prime of x. Yeah, so realize before you get started, 1 over x is x to the negative first. Yes? Are we all there? Okay, so now do your power rule, and we're going to have negative 1 times x to the negative 1 minus 1. What's that clean up to be? Okay. And negative x and negative 2 is fine. I left my negative 1 on there, but that's because of the next step. If we're not leaving a negative exponent, what do I do? Okay, so you're bringing the negative exponent down, and this is going to be negative 1 over x to the second. Okay. If you're in a situation where you just wanted to say negative x to negative second, you could. You wouldn't have to have the negative 1. Okay. E, f of x is 1 over x squared.
1 over 2x.
Nope.
-2.
So what is 1 over x squared written as a power? It is x to the negative 2. You don't get to use the power rule on just the denominator. We have to, make the whole thing x to some power. So, with that in mind, x to negative 2, so power rule says this is going to be the negative 2 out front, x to the what? Negative 3. So negative 2, x to the negative 3, or written without the negative exponent is negative 2 over x to the third.
Oh boy.
Are we all going at the next one? Okay. So what do we know about 1 over x to the 2/3? What'd you say?
You were wrong.
I thought you split
Not
the fraction exponent if you're
because we're dividing, but it's in the power form. If this was 1 divided by 2/3, then I'd be 1 times 3/2. But this is just an exponent. Okay. So you guys okay with it? As I said, everything you make into a power, right? So, are you there? Don't look up here till you're ready to check yourself. Although I'm going to wait to write the final step, but did you get your exponent? We move the negative 2/3 out front, and the exponent, I'm doing negative 2/3 minus 1. How do we minus 1 from thirds? Yeah, it's negative 2/3 minus 3/3, right? So negative 2 minus 3 is negative 5/3. Now, final answer.
Negative 2 over 3x to 5x.
Okay, so x to negative 5/3 goes down. That becomes x to 5/3 in the denominator. The 3's already in the denominator, the 2's in the numerator. The negative sign can either be with the 2 or out in front of the fraction. Okay. You seem to be doing fairly well with the power rule. It becomes, the more you use it, it just becomes very natural. Obviously, am I going to continue writing out the -1s and all of that? No, I'm just going to give the answer, and I think you guys are about there, at least on the easier ones, right? So. Now, the difference in this next section, they define it as the general power rule. It's still basically power rule. The difference is if there is a constant out front, so an A value, okay? So in that case, the idea is when you bring your in out front, that power out front, you're just going to multiply it by whatever's already there. That's all it's saying to do. Okay? So if there's a constant out front, it just carries down and it gets multiplied into the problem. So y equals 3x squared. To me, this isn't any different than what we've been doing. What happens? The 2 is going to come out front. And when I think of this, I usually think then 2 times 3 to the 3x to the 2 minus 1, which is just going to be 1. So y prime equals 6x. Are you guys with them? So, don't let that number out front do it. It's not going to hurt, It is what it is there. But s of t is negative 5 t to the third, so s prime of t what are you guys getting?
Negative 15t squared.
Okay, negative 15t squared. When you multiply your 3 and negative 5 and subtract 1 from your power. Okay, C, before you started, 6 square root of x can be rewritten as 6x to the 1/2, right? So, y prime is 1/2 times 6x to the 1/2 minus 1, which is negative 1/2. Half of 6 is 3. X to the negative 1/2. How are we going to express this answer? Three over x to the 1/2, which can become what's another way to write that? 3 over square root of x. I'm not saying you have to put it back in the square root form, but sometimes you want to. Are we okay with that?
Yes.
Okay. So I feel like I'm going quick in a way, but which is fine, as long as you guys are okay with it. D. First thing I'm doing is rewriting it without a denominator. Power rule only works when it's just an expression, no denominators. So I rewrote it as 3x to the negative second. So negative 2 out front times the 3x. And then subtract 1 from the power. So negative 6x to the negative third. If we express this in proper form, negative 6 over x to the third. Take the negative exponent to the denominator. Negative coefficient can be left up front. Okay. 4 over square root of x. This is what? 4x to the negative 1/2, right? Okay. What do we have? Negative 1/2 times 4 is negative 2. X to the negative 1/2 minus 1. It's negative 3/2, right? If you're subtracting 2/2. As we rewrite this without the negative exponent, negative 2 over x to the 3/2. Now, there's a couple different ways we can express that. I'll be honest, I stopped here. Okay? You could say this is a square root of x to the third. Okay, but it's not atypical to stop there in a situation like that. Okay. This one is negative 8 x to the negative, what's the original problem here?
4 over 3.
Which way did you say it?
4 over 3.
Because it's cube
4 over 3. I had a moment of hesitation myself. That was my pause. It's a cube root, right? Normally a square root, the 2 is in the denominator. It's a cube root, so the 3 is in the denominator. So the problem starts as negative 8 x to the negative 4/3. Okay. Negative 4/3 times negative 8 and x to the negative 4/3 minus 1. Oh, back up, back up, back up. Okay. How much should I explain here? Multiply the negative 4/3 times negative 8 out front, which I just thought of as 8 over 1, so it's positive 32/3 out front, yes. Negative 4/3 minus 1, so you're going to minus 3/3, so there's negative 7/3. And then negative 7/3 needs to go to the bottom. It's x to the 7/3 on bottom. The 3 is already in the denominator, so 32 over 3x to the 7/3.
Couldn't it be 32 over 3 to the cube root of x to the 7?
Yes. Okay. Tomorrow, I may tell you to do the first 4 on your own because it's just taking the derivatives of sums or differences, which is just taking the derivative of each term. So it'll be a good way to start off and review our rules from today.
Like that.
I told you.